Hello everyone, and I'm the third reporter of our group, and I'm going to report about the designing product layouts, line balancing, and the designing process layout. So first of all is the designing product layouts and line balancing. So the goal of the product layout is to arrange workers or machines in a sequence that operation need to be performed. The sequence is referred to as a production line or an assembly line. So these lines range from fairly short with just a few operations to long lines that have large number of operations. Next slide. Line balancing. A process of assigning tasks to workstations in such a way that workstations have approximately equal time requirements. So it is a technique used in production and manufacturing to allocate tasks across workstations in a way that optimize efficiency and minimize idle time. The goal is to ensure that each workstation has a similar amount of work, thereby smoothing the flow of production and reducing bottleneck. So, next is cycle time. The maximum time allowed is at each workstation to complete each set of tasks on a unit refers to the total of tasks to complete on a cycle of a process, from the start of producing to the finish a product. It includes all stages, such as processing time, waiting time, and any delays. Next slide. So here we have is the formula of cycle time and output rate. So output rate equal operating per day divide cycle time. So in cycle time is equal operating per day divided by desired output rate. So next slide is the the problem or the questions of the task times have governed the range of possible cycle time. The minimum cycle time is equal to the longest task time. So ang 1.0 is 1 is the longest is a minimum cycle time is equal to the longest, so it's 1.0, and the maximum cycle time is equal to the sum of the task time. So ang maximum niya is equals to i-total nimo ang 0.1 and 0.7 is 1.0 and 0.5 and 0.2 is equal to 0.5 mo na siya ang imong maximum sum of cycle time. So the the minimum cycle time would be applied if there were 5 workstations. So ma-apply ra nimo ang minimum cycle time na kuan if na ay isa ay 5 ka workstation. So the maximum cycle time would apply if all tasks were performed if all tasks were performed at a single workstation. So ma-apply ra nimo ang 2.5 minutes if there were naay 5 workstations. So the minimum and maximum cycle times are important because they establish the potential range of output for the line, which we can compute using the following formula. So ang computation is in the next slide. So assume that the line will operate for 8 hours per day. So 8 hours per day is equals 8 times 60 is equals for 80 minutes. So the cycle time na gamiton is 1.0. So ang use atong formula is kuan output rate operating per day divided by cycle time. So for 80 minutes per day kay 8 times 60 is for 80 minutes divided by cycle time 1.0 minute per day is equals for 80 units per day. So and the second is if we use cycle time of 2.5, so for 80 minutes per day divided by 2.5 cycle time is equals 192 units per day. So The third one is use the cycle time formula is for 80 minutes per day again, and divide for 80 per units per day is equals to 1.0 per units. So mo na siya ang imo ang cycle time of output rate. So next slide. Number minute equals a formula of number minute equals sum of tasks divide cycle time. So suppose the desired rate output of the maximum of 480 units per day. This will requires cycle time of 1.0 minute. The minimum number of stations required to achieve is this goal is. So in here is we have number minute equals 2.5. Okay, 2.5 man iyang minimum na kuan sa minimum number sa iyang kuan workstation required is 2.5 per unit. So divide 1.1 minute per units is equal to 0.5 per station. So next slide is next. Precedence diagram. A diagram that shows elemental tasks under precedence requirements. It visually portrays the tasks that are to be performed along with the sequential requirements. That is the order in which tasks must perform. The diagram from left to right, the initial tasks are on left, so the final task is on the right. So first we have here is the workstation 1 and 2 and 3. So then we have a time remaining, so ineligible, then assigned task and revised time remaining. So in workstation idle. So first we're going to left. So first we're going to go in workstation 1. So the remaining time is 1.0. So let's start in 1.0 to eligible E to B. So E to B is at the assigned task. So 0.1 from E to B, 1.0 is 1.0 minus 0.1. So as you can see in the revised time remaining is 0.9. So that's gonna be 1.0 minus 0.1. So then the result is 0.1. So in the second row is 0.9 eligible B to C. So B to C is 0.9. So in the C is has 0.7. So 0.9 minus 0.7 is equal to 0.2. So in the third row is 0.2. So because in the revised time remaining has a 0.2, and you go into the third row and you will get 0.2. So the eligible in the third row eligible is none and none. So the station idle time is 0.2, and workstation 2 is, and I'm going to workstation 2. Time remaining in workstation 2 has given 1.0 going to eligible to B, assigned task to B. So 1.0 in workstation B, in workstation 2 has 1.0. So 1.0 in the time remaining minus in B workstation 2 1.0 is equal 0.0. So why is it equal 0.0? Because it is fully utilized with no idle time. So we're going to move in workstation 3. So 1.0 be eligible to D, assigned task to D. So 1.0 minus, as you can see in D has a 0.5 minutes. So 1.0 minus 0.5 minutes is equal to 0.5. The time revised is 0.5. So in the second to the last row has 0.5 because 1.0 minus 0.5 equals 0.5. So, next is E to E, eligible to E, assigned task to E. So, from E to E, so from 0.5, you're going to deduct it from E. So, 0.5 minus 0.2 is equal 0.3. So the time revised is 0.3 and the last is 0.3 and eligible to none and none is equals to ang station idle nila kay kuan from workstation 1 to workstation 2 is 0.0 and 0.2 and in workstation 3 is 0.5 over 0.3 over 0.5. So next slide is balance delay is the measure of inefficient in production line caused by an even distribution of work among workstation. It reflects the percentage of idle time relative to the total available time for production. So, the percentage of time, idle time of line. This is referred to the balance delay. So, as you can see in the formula here is percentage of idle time equals idle time per cycle divided by number actual times cycle time times 100. So where number actual equals number of stations. So for the ang example nato niya is percentage of idle time is equal. So we're going to use is 0.5 equal over divided by 3 times 1.0. So if you divide it in, if you're going to multiply first the 3.0 3 times 1.0 is equals 3. So 0.5 divided by 3.0 is 0.1666. So ang result is 0.1666. So you're going to move to the 2 decimal. So 0.16. So kay 0.666 man 1666. So i-round off nimo kay 6 man is above man siya sa kuan 5. So i-round off nimo ang isa ka 6 to 7. So mahimo siya 0.16.7. So i-multiply nimo og 100. So muna siyang result is 16.7. Next is the efficiency of the line. So, inani siya pag-compute efficiency. So, equal 100% minus time percent of idle time. So, pwede na nimo siya ihimo og 100% pag naka-compute na ka sa imo ang sa percentage idle delay sa imo ang una. So, pwede na nimo siya 100% minus 16.7% is mo result na siya og 18% ay 83.33. So, pwede po nimo og pwede po din ani efficiency equals number actual times cycle time minus idle time divided by number actual times cycle time. So first imo siyang sa taas imo siyang i-multiply og i-minus. So imo siyang gamiton ang efficiency na formula. So 3 times 1.0 is equals 3 minus 0.5 is equals 2.5. So, sa ubos niya kay 3 times 1.0. So, ang equal niya 2.5 times 2.5 divided by 3. So, equals, i-divide nimo ang 2.5 divided by 3 equals 0.8333. So, 8333 dayon. So, i-move nimo into decimal. So, di man siya ma-round out kay below man siya sa 5. So, So, i-multiply nimo og times 10. So, equals 83.3. 83.3%. So, next slide. The parallel workstations are multiple workstations perform the same or similar task simultaneously with the production process. This configuration is often used to increase throughput, reduce bottleneck, and improve efficiency. So, as you can see in the chart, is has 1.0 and 1 minute to 60 hours to 1 minute, and to and the bottleneck is on 2 minutes, so 1 minute go to 30 hours. So 30 hours and 2 minutes to 30 hours, and 30 hours to 1 minute to 60 hours. The model line of the model line. A line handle more than one product on the same line. This approach offers great flexibility in varying the amount of output of the products. Next slide. Designing process layout. The main issue is the designing product layout concerns the relative positioning of the department involved. The problem is to develop a responsible good layouts. Some combination will be more desirable than others. One advantage of a processing layout is their ability to satisfy a variety of processing requirements. Customers are or material in these systems requires different operation and different sequence of operation, which causes them to follow different paths through the system. Next slide. So this is the list of information requirements. So first is a list department of work centers to be arranged. Their approximately dimension and the dimension of the building, or the building that will house the department. So this layout optimizes workflow by placing departments on logical sequence from receiving to shipping, minimizing handling time, and improve efficiency. The arrangement supports operation needs while allowing for flexibility and compliance with safety and standards. So number 2 is the project of future workflows between various work centers. This projection helps anticipated resources allocation, staffing, and potential bottleneck, allowing for proactive adjustment in workflow designed to enhance efficiency and responsive to market demands. Third is the distance between location and cost per units, or of distance to move loads between locations. Understanding Understanding distance and cost is crucial for optimizing logistics and minimizing transportation expenses. This analysis can be guide decisions on layout designs, equipment need, and process improve, ultimately enhancing overall operation efficiency. Number 4 is the amount of money to be invested in layout. This refers to the budget allocated for design and implementing the physical arrangement of work centers. This includes cost of constructions, renovations, equipment, and purchase, and any necessary technology. Number 5 is a list of any special consideration or operation that must be close to each other or operation must be separated. So these special considerations involves identifying specific operational needs that affects layout direction. For instance, some work center may need to be located near together for efficiency, such as those that rely frequent communications or material transport. Conversely, certain operation might be require require separation to enhance safety, minimize distractions to comply with the regulation. Number 6 is location. The location of key, utilize access and exit points loading docks, and so on its existing building. So, identifying where water, electricity, and HVAC systems situated as well as entrance, exits, and loading areas receiving from dispatch and goods. Next slide. So, minimizing transportation costs or distance. The most common goal in designing process layout are minimizing of transportation costs or distance travel. So, as you can see in table 6.5 is you can see is from the location is to A to B to C. Then A to A to B is 20 meters. So from B to C is 30 meters. Then from C to A to C or C to A is 40 meters. Then in the department is from 1 to 1 to 3 department is from 1 to 3 is 170 and 2 to 3 is 100 and 3 to 1 is or 1 to 3 is 30. 1 to 2 is 30. So ranking the departments according to the highest workflow location, according to the highest enter locations distance, help making assignments. Next. If the cost per meter to move any load in $1, you can compute the total daily transportation cost for the assignment by multiplying each department number loads by trip distance to summing those quantities. So as you can see in the chart, there is department 1 and department 2 and number of load between, then location, distance to load times distance. So 1 to 2 is, as you can see, is 1 to 2 is 30 load and 3 is 170 and 100. So distance is 40 to 20 and 30 to 30. So gibalira ni siya ato sa last na chart, gihimo siya og ang sa taas kay ang sa ubos kay 30 niya gibalin niya sa ang sa taas ang number of load is 30, so 100 or 100. Location is E to C dayon. So load times distance is 30 times 40 is 120,000. So 170 times 20 at distance is 3,400 and 100 times 30 is equal to 3,000 and 100 to times 10 is equals to 3,000 and i-sum up nimo sila is 1 2 plus 3 4,000 plus 3,000 plus 3,000 is equal 7,600 imong mabayad sa imong kuan sa imong load. So muna siya, then ang total niya sum. So next slide. Closeness rating. So Richard Motter developed a more general approach to the problem which allows subject input from analysis or managers to indicate the relative importance in each combination of department pairs. So this image represents diagram of the relationship and distance between the difference. So the department 1, 2, and 3 and location E, B, C here explain that the closeness of the rating chart. So the circle labeled 1, 2, and 3 are represented as a department. So the green labeled E, B, and C, they represent their location where the departments are placed. So the line numbers connected to the department, which shows the load of movement between them, with the numbers next to the line representing the number of load exchange between departments. The value associated with these connections are Department 1 to A to Department 2, Department 3 is B 170 loads, so Department 3 B to Department 2 C 100 loads, so Department 1 to A to Department 2 to C is 30 loads. So distance, the layout also shows the distance between the location of B and C corresponds different paths. So next slide. So process selection and facility layout. So first is the simplified illustration. So ang the code of closeness diri is A is absolute, E is very important, I is important, O is on ordinary importance, U is unimportant, X and undesirable. So simplified illustration, they use the same equipment or facilities. 2 is they share the same personnel or record. Number 3 is required sequence of workflow. 4 is needed to is communication. 5 is would create unsafe and unpleasant condition. 6 is work is performed. So 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 the grid in the same way as you would read the mild age chart on the road map, except that the letters rather than distance appear at the intersections. The letter represents the importance of closeness of each other department pair, with A being the most important and X being an undesirable pair. Thus, in the grid, absolutely necessary to locate 1 and 2 close to each other because there is a intersection of those departments on the grid. On the other hand, 1 and 2 should not close together because their intersection has an X. In practice, these letters on the grid are often accompanied by numbers that indicates the reason for each assignments. We are omitted here to simplify the illustration matter suggest. So that's all my report. Thank you.